Good morning, everyone. Today we are going to start a 5-day technical development program on operational research and optimization technique organized by VLT University. This is the first day of first session. So now let me introduce our first speaker, Dr. Prabhishek Mahapatra. He has done his bachelor's degree in computer science from Nalanda University, Odisha in 2009. He has done Master of Computer Applications in 1 year from SRM University in 2010. He has completed Master of Science in Mathematics and Computing from IIT Guwahati in 2012 and completed his PhD in Operation and Research from Computing Technique from NIT Silchar in 2018. His area of interest is evolutionary algorithms, soft computing technique, evolutionary algorithms, multi-objective optimization, large-scale optimization technique, fuzzy technique, renewable energy, and applied mathematics. His total citation is 2,212 with H index of 7, I-10, 4. He has experience with 4.5 years and currently is the assistant professor in Department of Mathematics in VIT University, Indore. So I'm welcoming Dr. Prabhjit Mahapatra. Uh, Over to you, sir.
Yeah, good morning to everyone. Let me share the screen. Okay, so am I audible? Am I audible? Am I audible to everyone? Okay, so the first session of the 5-day FDP is going to start, and today I'm going to give you one what is that the brief introduction about the soft computing techniques to solve the global optimization problems. So soft computing is so many in the soft computing so many things are there, but I'll focus what is that particularly about the evolutionary algorithms. So how to solve the optimization problems. So what we are going to discuss, we are going to see what is optimization, what type of optimization techniques are there, then how meta-heuristic algorithms are useful, what are the types of meta-heuristic algorithms, then we'll see some particular meta-heuristic algorithm which are very much popular. Okay. For example, the PSO, graph optimization, Firefly, differential evolution, all these things we are going to, along with this, we are having some other algorithms also. So these algorithms, we are going to see them thoroughly. Also, we'll see what are the recent trends algorithms are there, recent works are there, and what can be the future work. Okay, what is the future scope in this area? These are things we are going to discuss. So let me start with the optimization problems. So what is optimization? Optimization is there in all the areas. Okay, so if you are working in chemistry, if you are working in mechanical department, if you are working in electrical, if you are working in civil, irrespective of your discipline, people in all area, they are using the optimization techniques. Okay. So even the physics people, the math people, we are already doing. Okay. Physics, chemistry people, they are also using. So it is like interdisciplinary, completely interdisciplinary. So what is the optimization? Optimization problem is nothing but the finding the optimal solution among all the feasible solution. Feasible solution means you will have some restrictions. Okay. It is not among those restrictions. Okay, that x value should lie in between 1 to 5 or y value will lie in between this to this. Okay, or whatever the restrictions will be there. So among those feasible solution, you need to find what is the best solution which is satisfying your objective function. So optimization problem means you will have the objective function, you will have the constraint, you will have the decision variables. Okay. So these are the three, what is that, parameters of any optimization problem. So like I created the first WhatsApp group. There also I gave the, what is that, a group icon. You can see there. So the for any optimization problem, we are having the main three parameters. What are that? Objective function means what we are going to maximize or minimize. We'll have the set of constraints, equality or inequality. Constraint means nothing but the conditions. Okay. Then the decision variable, whether you are having a two variables or you are having three variables or you are having multi variables. Okay. Depending on the situation, here, what is that? Your optimization problem will be formed. Okay. So you're having the optimization. So in general, mathematically, you can say that in symbolical form, you can write in function form. Okay. So optimization problem are various type. It can be discrete, it can be continuous, depending upon your situation. Okay. Then if we are going to classify our problems, okay, that optimization problems, there are here in my slide, I have written only two types. It is not like that. There are several types are there. Okay. Mainly, if we are classifying, then you can write that, okay, this is single objective optimization problems and multi-objective optimization problem. Okay. So single objective optimization problem techniques are different and multi-objective optimization problem, for them separate techniques are there. Okay. So they are, what is that, completely different single objective and multi-objective scenarios. Okay. And not only that, you will have, what is that, you will have the high, large scale optimization also there, small scale optimization also there. Okay. So there are several types of there. But mainly if your people are saying that, they will say that, okay, single objective there, multi-objective. Single objective means only one objective function will be there. Either you want to maximize it or minimize it. For example, I am having one company, I focus on, what is that, maximize my profit. Okay. Or I'll consider minimize my loss. So only one objective function, either I'll consider maximize my profit or I'll consider minimize my loss. Okay, this type of problems only single objective. So it is called as the single objective optimization problem. Multi-objective means multiple objectives you will have multiple. So you need to maximize the profit. You need to invest also less, or you need to, what is that, minimize the manpower. You have to minimize the time. See how many restrictions I am giving. I'm not only saying maximize my profit. I'm at the same time I'm saying minimizing my time. I need to work the done in less time. Okay. So that single objective, no one was saying about the time. Now I added the restriction time. I can say that minimal labor cost. Okay. Means the manpower also I'll use minimum. But at the same time, profit also will be maximized. Okay. So it is like contradiction statement something like that. For example, I'll give one best example. If you're going to buy one car, okay, four-wheeler car, you're going to any showroom. You're going to the showroom and you're asking the, what is that, to the showroom, the guy, that you give me the car which will have the least cost or the least cost. Okay. I would say the least cost. Okay. And with the maximum comfort. See, if you're buying some Audi car or some what is that luxury car, there you will get the maximum comfort, no doubt. Okay. But thing is that the cost will be heavy. Cost will be around what is that 40 lakhs, 50 lakhs or 1 crore like that. But if you're going for Alto or 800, okay, Maruti 800, Alto, this type of cars, okay, then cost will be very less, okay. But think at the same time, your comfort will be also less. These are see exactly contradiction statements. So you are saying I need what is that? I need the minimum. I need to invest the minimum cost, and I will get the maximum comfort. So the representative, the sales guy will say, sir, whatever you are saying, that is completely contradiction statement. There are two objectives and you cannot attain both the things at the same time. So you have to you have to find some compromise. Either you compromise with the cost, otherwise you compromise with the comfort. So these type of scenario are called as the multi-objective scenarios. Okay, multi-objective problems. So there here I am saying only two objective function. You can have more than two objective functions, okay, but at least two objective functions will be there. So this is the scenario of the single objective and multi-objective. So algorithms that are designed for single objective are different. Algorithms that are designed for the multi-objective different. Some single objective algorithms, they have been extended to solve the multi-objective problems, but they are not that much efficient, okay. The scenario is completely different. I said why, okay. Okay, so these are the now if you're coming to the optimization techniques, the optimization techniques are several types. Optimization techniques are several. Just a minute. Just a minute. So the optimization techniques are several types, mainly the traditional, non-traditional, non-traditional techniques are there. And so here, the actually, our topic is coming to the pictures here in this slide. Okay. So the traditional and non-traditional techniques are what is that? Completely different things. Okay. Traditional techniques people are using from many years. Okay. Many years, at least some, what is that? I would say that many decades. Okay. And using like the normal derivative differentiation, those things. Okay. Non-traditional technique means the technique that we are going to discuss in today's lecture. Okay. So there is, what is that? There is no differentiation. There is no need to check any continuity. Nothing you need to check. Okay. So it is completely different things. What is the traditional? Traditional techniques means you need to see whether the function is differentiable or not. Then differential means we all have studied now in class 11, 12 to find the maximum point, to find the minimum point. You take the first derivative, then you find the extreme points. You take the double derivative. Okay, you check. So like the gradient descent method, so many methods are there. Okay, so you need to see that where the derivative is increasing, where derivative is decreasing. Depending upon that, you can decide whether it is a maximum point or minimum point. Getting enough. So the traditional techniques are depending, what is that? Completely depending upon the function. If the function is continuous, if the function is differentiable, if the function is continuous, if the function is differentiable, then only you can apply the traditional techniques. And the non-traditional, and what is that? It is the final solution is going to depend upon the initial chosen solution. Okay, like the iterative methods like that. Okay, so it is slow, but it guarantees that the obtained solution will be the global. So here is the main difference. Okay, traditional method, the obtained solution will be it will give you the guarantee that it is a globally optimum solution. Okay. And optimization problem involving discontinuous objective function cannot be tackled. Like I said, if it is a discontinuous, you cannot find the derivative. You cannot, what is that? Use the gradient based method. So because function is discontinuous means how you are going to find the derivative. It is not going to be possible. So So there exist various of optimization problems. Okay, in traditional method also so many things are there. Now, if you are coming to the non-traditional optimization technique, you don't need any concept of differentiation. You don't need what is that continuity. Those things you don't need. Okay. So in non-traditional, the meta-heuristic is the one of the important tools. Okay, the meta-heuristic algorithms. So the meta-heuristic algorithms, actually it is heuristic. Meta-heuristic means if meta means what? If it can be applied in different types of problem, then it is meta-heuristic. So heuristic means there is nothing but the your what is that? The swarm-based methods, evolutionary-based method, physics-based method, bias-based method. So evolutionary algorithm like genetic algorithm, differential evolution, they are swarm intelligence based methods are there, PSO, GRAIL, so many algorithms we are going to discuss. Physics based methods using the physics concept, bio-inspired means some biologically inspired algorithms. Okay, so several types of meta-heuristic algorithms are there, and the people are doing the contribution, what is that, for many years, and it is like some saturation period. Like there are thousands algorithms are there. Okay. So it can solve any types of optimization problem. Okay. So that much of algorithm have been proposed, what is that, in past. Okay. So nowadays it is very less scope to propose something new. New algorithms you can propose, okay, depending upon some mechanism. But thing is that it is not going to give you guarantee that the result will be superior than the available results. Okay, like if the optimum value is 0, people have already, what is that? They found the value as 0. Then what you will do? So that is the minimum value 0 already people have found. So if you are proposing new algorithm, you cannot find better. Now already better has been found. So that is what we are discouraging people to propose new algorithm. But you can do what is that, you can extend the work, existing work. You can modify the work. Okay. So existing algorithm you can improve instead of proposing new algorithm. So there, but thing is that still people are doing, some people are doing, you can also do, we are also doing. So what is that, today's lecture you will get that idea how to propose new algorithm, how to propose new technique. Okay. And so it is going to help you a lot. So main thing is that you can apply in your area. One second, please mute yourself. Okay, so the first one we are going to discuss the PSO, particle sum optimization algorithm, and it was proposed by Kennedy and Eberhard in 1995. And it is nothing but it is, what is that? The algorithm was proposed by following the behavior of flock of birds. Okay, or you can say the swarm of fish. Okay, or like a group of animals. Okay, and where the group of animals they are staying together, and if they are moving means one animal or one bird or whatever you can say is following his in other animals behavior in that group. Okay, it is not like that one will work independently, they are working in a group. Okay, so here what is that, for how I'll give you example. See, if you are, for example, if you're throwing some rice on your rooftop, okay, you're having your own house. So where you're living, you put some rice on the top of your floor, okay. So you will see within some 5-10 minutes, some bird will come. After that, some if you're having more rice, okay, if you can put, then you will see after that some 20-30 birds will be there. If you're putting bags of rice, then after some time you'll see hundreds and hundreds birds will be there. Birds means crows, those things will be there. Okay. So how you seeing, how you can you observe the pattern? So it is not like that the who is taking the food on your rooftop, who is taking the rice, he is going and what is that? He is calling. It is practically invest. So they are having the coordination. Okay. So people, what is that? They are living in a group, so they are following each other's behavior. So if one is going there, then the who is sitting next to him on another rooftop, then he is coming. By seeing that guy, another bird will be sitting in some other rooftop, and he is also following the second one's movement. So like that, they are making the coordination. And for example, your neighbor is putting some rice on his rooftop. Then you'll see some birds, they will move to your neighbor's rooftop. But the birds are too much intelligent. They will decide the place depending upon the food availability. If your rooftop is having the maximum food, then you'll say that all the birds will stay in your rooftop. Although on your neighbor's rooftop also some food are available. Okay, birds are intelligent. So here what is happening? The particle means you can consider the bird. Okay, the bird or you can say the crow. Okay, so what it is doing? It is checking the best solution. Best solution means where you are having the maximum food source, and his personal best also is saying personal. That is his personal means near to his area, okay, where he can get the maximum food source. And total area, total means that is nothing but global base. For example, whole, what is that? Whole that area where you're going to find the uh, optimum value. Okay. So in your whole area, there also somewhere you will have the maximum food source. So that is nothing but the global base. So you here you're having one P based, another one the G based. P based is nothing but the personal based that particles personal based means near to its dish, what is the maximum food source available, and another one is the global based that among the whole area, what is the maximum food source is available. Okay. So you depending upon that, you are going to have the P based and G based. And here each particle means each crow or each bird will have its current position, it will have its current velocity, and you can what is the resultant vector between the current position and P based, current position and G based. I'll show you the equation. So here, what is happening here? This is the very interesting you see here. So the bird is staying here, okay, and his personal best is this P based. You can see like near to his where he is sitting, there he found this is the best food source available. G best is that which is the best among all the birds. Okay. For example, there are some 10 birds. Each bird will have his own P best, which is the best among all the 10 P best is nothing but the G best. Okay. So the bird has to decide whether he is going to go for P best, whether it is going to go to G best. So there is a resultant vector is there. Okay. And that equation is, so here this is the V means the velocity, ith particle velocity, X stands for the position, ith particle position. So it is nothing but P best minus XIT, T stands for the Tth iteration. Okay. So P best minus Xi, that means this green color you can see, this is a resultant vector. G best minus Xi, this is another resultant vector. So if you are adding these two terms, then he will reach in the, you can see this some orange color line. So this Xit plus 1 is going to be its next position, next movement. So why this is happening? So you can ask that he can shift to the G best or he can shift to the P best. Why is shifting to Xit plus 1? Main thing is that in our source space, we don't know where actually our optimum solution is there. So these are all what is the stochastic base. We are going to find the solution. What is that? Complete blindly. So we are having the intelligence that in the direction of P best, some food is there. In the direction of G best, maximum food is there. It may be possible near to G best, the what is that? The best among all the best among all the P best or best among it is possible that the food source, the available food source, the amount of available source would be better, even it will be better than the GBET. It may be possible, who knows? Okay. So in optimization problem, nobody know where you are having the optimum solution. So we have to go complete blindly. So it may be possible near to G base, you can have the what is that? You can have the top chance. Okay, you will have the maximum food. So it may be possible. So that is why we are using the intelligence of P based and G based. So if you are going to G based, then you will fall in the local optimum. Okay, so we need to avoid the local optimum. Rather, we need to search near to that optimum solution. So till now, our base solution is G based. So we need to find near to that G based or near to that P based. So that whether you need to move more towards P based or whether you need to move more towards the G based, it depends upon the C1 and C2 factor. The RAND is nothing but the random value in between 0 to 1. And the C1, C2 is the weight value. So that if you are giving more C2 value means it will move more towards the G base. If you are giving the more C1 value means it will move towards the P base, depending upon your scenario. Okay. So the P base is very good. Okay. But thing is that this algorithm used to fall in the local optimum because this is what is that term. It will find the optimum solution very fastly. Okay. Very fast convergence rate. But thing is that it is having the record to fall in the local optimum solution. Okay. So means diversity is not that much. So in any optimization algorithm, we need two things. One is the convergence, another is the divergence. Diversity means you need to search thoroughly the whole area. That is about the diversity. Okay. Convergence means once you're finding the solution, your solution should converge. Means it should give the optimum solution as soon as possible. Okay. So convergence and divergence is there. Two things are there for any optimization algorithm. So the PSO is good. Convergence is very fast, but problem is that it will fall in the local optimum solution. Okay. Many cases it used to fall. Then we are having another one popular algorithm, Gray-Wolf optimization algorithm. So the Gray-Wolf optimization algorithm mimics the leadership of or the hunting mechanism of gray wolves in nature. Okay. So the wolves they are having three mechanism. What is that? They will the main steps of hunting that they will source the prey, they will encircle the prey, and they will attack the prey. They will sort the premise where they can attack, where the prey is there, for their food source is there. So once they are saying that okay, here is the prey, then the second one they will encircle the prey. They will encircle means they will what is that? They will they will spread around the prey. Okay. Then once they what is that encircle the prey, then they can attack the prey. So why this is happening and how the optimization algorithm is developed. See here, that prey is nothing but you see any optimization algorithm, we should have some intelligence to move in a direction such a way that we can find a global based solution. That is for any optimization algorithm. That intelligence that algorithm should have. Here, in this algorithm, the prey is nothing but your best solution. For example, you are having some 10 solution, means 10 food source available. I'm just giving the same food source and pro example, okay? And it may be possible, okay, among those 10 food source, which is having the highest amount food source, it may be possible near to that house, you'll have better opportunity. It may be possible. So that is why for any optimization algorithm, we will always follow the global optimum solution. The global means which is best available solution till now. So whatever the best available solution, if you're going in that direction, it may be possible. What is that? Around the global optimal solution, you will have the better opportunity than that G-based. You can have your solution can be improved. So if your solution is not improving, then how will you find the better solution? So each iteration, each step, your algorithm should give you the intelligence to improve your solution. At the first step, for example, this is minimization problem. When you run the algorithm, first you got 15. Next step, you should get 14. Next step, you should get 13. Or if it is a maximization problem, first step you got for a first iteration, you got 5. Next step, you should get 6. I'm just giving example. So your solution improve. And for example, the global solution is 100. Then 5, 6, 7, 8, 11, 15, 19, 20, 30, 40, like that it should go to 100. Understand or not? No one knows where you're having the maximum solution, what is going to be the maximum value. So we'll keep on trying. We'll keep on trying to improving our solution, and till we'll have the time, what is the number of iteration, depending upon the number of iteration, we'll go for the what is our best available solution, that is going to be the GBest. So here the prey is nothing but your best available best available optimum solution. For example, my best available solution is one position I got. So I will move towards that direction. So here all the particles means all the gray wolves, or you can say here all the crows or all the birds, they are here the gray mechanism, how it is working. They are moving towards the best optimum solution. The best optimum solution is nothing but your brain. Okay. But thing is that this algorithm is designed. This algorithm will have what is that? Here you will have mainly three things you will have. Okay. So this position you can see they will update their position using x1 plus x2 plus x3 by 3. So what is x1, x2, x3 by 3? So you will have three types of gravity. One is the alpha, beta, delta, and omega also there. Omega are nothing but we mainly in this algorithm, they will take the alpha, beta, and delta. Alpha is nothing but the top. What is that? What is that? Which is the solution is having the best solution, which is the G best. Okay, the top one. Okay, then the second best is nothing but the beta. This is the best one. This is the second best one. This is the third best one. And the other thing you can, what is that? You can keep it in omega. Okay, which are actually the weaker. The what is that? The baby is the what is that? The female graves. Okay, which are older graves. Okay, which are aged graves. So those are in the omega. Okay, so mainly you will have alpha, beta, delta. So alpha, beta, delta is nothing but the in the what is that? The alpha is the top one, beta is the second top best, and delta is the third best. Then you can take average of these three. So that means we are taking what is the average of base three, and depending upon that, so that means see you can say I can take the top one, like you said that prey is the what is that? Prey is the nothing but the best one. So we should all move toward the best one. See, if you're moving in that direction, then 100% chance that you will fall in the local optimum. So we have to avoid the local optimum. So to avoid the local optimum, what we are doing, instead of taking only alpha, we are taking the best, second best, and third best. So that means the diversity will be there. So you are not going towards only the best one. What is that? You are taking the average of three. So it will coordinate, it will find the mean of best three, and it will give you the some position. Okay. And all will move towards that direction. So this is your what is that? The updated position, that is nothing but the average of base three particles position, and all are moving towards that direction. Okay. So it will improve your performance. Okay. So this is one very, what is that, very effective algorithm is there, Grave optimization algorithm. Okay. And there the parameters are there, R, A, all these things are there to control your convergence. So once you are getting the good solution means it should converge. Okay. The algorithm will work in such a way that first it will focus on the diversity. It will search thoroughly whole area. So once it got the optimum solution, then it will start converging. So these R values, A values are nothing but the convergence parameter. Okay. It will give you a solution very quickly. Okay. Then you are having another algorithm, Firefly algorithm. This is also very popular algorithm. So in today's lecture, whatever algorithms we are discussing, all are, what is that, very popular. Okay. So the people have done what is that, 1,000 contribution for each algorithm. There are 1,000 PSO variants. There are hundreds of GW variants. There are hundreds of Firefly variants are there. Okay. So these algorithms were peak in their time. Even in today's time also people are using those algorithms to solve many optimization problems. They are trying to improving their performance. They are doing so many things. Okay. So these algorithms like the benchmark algorithms are very much popular. Okay. In evolutionary algorithm. So Firefly, we know what is that, in our childhood days, we used to see the Firefly. Okay. So Firefly, what it is doing, it is always the Firefly, it is, it will have some light intensity. Okay. So where you are having the light intensity, then so other Firefly, they will move towards in that direction. But here, so that the same concept only. So you will have one G based. Okay. We will have the best fitness value. We will have the best solution where you are having the maximum food source. So here the food source is not there. Here each Firefly will have some intensity. So Firefly are nothing but the particles in your whole, like here in metastastic algorithm, we will take some random solution. Okay. In your source space is there. We don't know where you are having the base solution. So we'll take randomly some 100 particles or some 200 particles. Okay. Depending upon your situation. Then which is having the best solution, which is having the best optimum solution, others will follow to that direction. That is the mechanism for any algorithm. Understand or not? For any metastastic algorithm, you find where you are having the base solution, then you give some intelligence to move towards that direction. You will see in PSO, you are having G based and P based. So people, all the particles were moving towards the G based. Then we saw the gray wool. There you are having alpha, beta, delta. So average of that three, average of best three, that is also best one. So all are moving toward that direction. So each algorithm have some intelligent technique. Okay. Here Firefly, each particle or each particle is a Firefly. Okay. Each particle is an insect Firefly, and it will have some light intensity. Light intensity is nothing but in terms of fitness value. So if someone is having the, what is that? Fitness value is nothing but the objective function value. Okay. If some particle is having the good objective function value means its light intensity will be more. If one is having less objective function value means it will have the less fitness value means it will have the less intensity. So if someone is having the, what is that, good intensity, others will follow in that direction. That is the technique. Okay. And there another thing matters about the distance. So if distance is far, then one will not follow na, because it is too much far. So intensity also will decrease. Okay, because distance with distance also. So why I'm saying if your optimal solution is very much far, so why you move to that direction? So you see in your neighbor. Okay, you see near to your area. So that is the main mechanism of this algorithm. So here you will have the light intensity will have, and here R is nothing but stands for the your distance, and here you will have, what is that? So they are xj xi means, so two particles here, xi is going towards the xj. Condition is that xj light intensity is more than xi. then only it will get attracted. No? Otherwise, means fitness value of xj is better than the fitness value of xi, or the objective function value of xj is better than the objective function of xi. That is why xi is moving towards xj. So you can see this is I, this is j. J is having the j is the best firefly or best solution. Or this is a worst solution. Okay, so this one is moving towards this. It is going to depend upon the distance. If it is too much far means it won't follow. If it is near to his position means it will follow, and which is the best one. Yeah, so all are moving towards. So all algorithms having some intelligence. It is directly you move towards good position. You move towards the optimum solution. So the solution is improving. This is the main mechanism of any meta-heuristic algorithm. Okay, so what is that? I'm discussing so many algorithms in very less time. Okay, so you may not able to understand each and everything. So this is just like an introduction. If you have the interest, then what you can do, you can. So there are MATLAB codes, YouTube videos. There are several are there. Okay, so you can follow anything, or you can contact me also if you're having any doubt. Okay. And so what is that? I'm just discussing many algorithms in quick interval of time. Okay. So this is Firefly also very much popular. Then you're having the sine cosine algorithm. Sine function everyone knows. Cosine function also everyone knows. So depending upon the sine cosine functions, this what is that? The Syed Ali Mirza Ali, he is very much popular. Okay, in proposing. So all the even the Grail optimization he has proposed. Okay, so many algorithms he has proposed. Okay, and then I'll show you another WA also he has proposed. Several algorithms he has proposed. Okay. So depending upon the sine cosine function, you can have the so sine cosine are periodic function. You know, so they are if you are using the sine cosine function, they are balancing the what is that convergence as well as diversity very nicely. So it is also very much popular. Okay, this is then we are having the Whale optimization algorithm. This one also proposed by the Syed Ali Mirza. Okay, so here also you can see the Whale is there, but it will search for the prey. Prey is nothing but your best solution available, current best solution available. Okay, then and this whale is nothing but the other particles. So all wants to go in the direction of the base solution or not. That is the technique. So here the whale is going, what is that? Like the circle ring type, it is making the path and it is going. So if you are going directly, it is not that it is going exactly to the prey or it is exactly going to the best solution. No, it will go near to base solution. It may be possible because base solution already has been found. Na? So what is use of to go to the same position? We won't go to the same position, rather we'll search near to that position, near to the base solution. So it may be possible that you can find better than that existing base one. Your solution can be improved. It may be possible. So that is why it is making circular like circle like path to reach to the prey, but it won't reach, but near to that prey, it will, while going wherever it is finding better solution than the available best one, then it will replace the old one and it will pick the new one as the best solution. Okay, this is the mechanism. Then we are having the differential evolution algorithm. Differential evolution is very old algorithm, okay, but it is having good diversity. PSO differential evolution are very old algorithm. They are still popular. Differential evolution also 1000% are there, okay. So differential evolution, what I was saying that this is better than PSO. Why? PSO convergence is good, but divergence is not that much good. But differential evolution, divergence is very good. Okay. Even nowadays also people are using. So differential evolution, there are main three things: mutation, crossover, and selection. And using the genetic algorithm, same type of mechanism there. But differential evolution, So what is that? There are several types of differential evolutions are there. You can have the P-based concept, you can have G-based concept, and concept you can take. There are several types of there, but diversity is very much good. Okay. So then recently, whatever the algorithm we have proposed that I'm going to discuss. Okay. So one algorithm is American Zebra Optimizer algorithm. Recently we have proposed. Okay, and it got published in this March. Okay, March April it got published, and it came online. I think April first week or like that. Okay, so in 2023 it got published in a safe journal, and it is Q1 and impact factor 4.9 almost 5. So it is like it is nothing but the mimicking the behavior of the zebras. Okay, so zebras are very much sensitive animals. Okay, they won't mate with their family members. Okay, they won't do the reproduction with their own siblings. Okay, so what they'll do, so the baby zebras once they got mature, they will leave their group, they will go to some other group, and there they will do the reproduction, or they will do the what is that family. So they are very much sensitive. So here the zebras, they'll make the small groups. So once the each group will have some baby zebras, once they matures, they move to the another group. So here the diversity is happening. Then each group will have some leader. Each group will have some leader you will have, and that leader is balancing the convergence. So what convergence? He is taking the group where the maximum food source are available, where the water is available, where the grass is available. The leader will be there. So here the convergence as well as diversity. Convergence is maintained by the team leader in each group, and the diversity is maintained by how the baby zebras are moving to the another group. So we have checked with several benchmark functions and we saw that good results are coming. Okay. So yeah. Then we are having the we publish another this one just published in last month only in May. It got published in knowledge based systems, and knowledge based system is very much popular generally in our area. It is having the impact factor 8.139. So here what we have done, we have there is a golden jackal optimization algorithm is there. So using the behavior of golden jackals, okay, they're also same thing, the hunting mechanism. But we have improved the what is the golden jackal optimization algorithm by proposing one new technique. See, nowadays, if you are proposing new algorithm, it is very much challenging. We are having many idea. We are having. We can propose several. What is that new optimization algorithm? But what the trend is there? They are discouraging in proposing new algorithm because there are thousands algorithms are there. Na? People are saying you use the existing algorithms first before proposing new. If you're proposing okay, but what you will give? The optimum solution is already zero for a minimization problem. Optimum solution zero. Thousands algorithm they already got zero, and your algorithm also will give zero. Then what is new? No extra things are there. Na? Okay, you can mimic the behavior of any animal. You can design one algorithm, that's okay. But in terms of result, the results are not what is that already optimum solution, already many algorithm they got. So they are discouraging, but they are saying that the existing algorithm you try to improve. So that attempt has been done in this part. So we propose one new technique that is called fast random opposition based algorithm. So fast random opposition based technique, and we implemented on the golden jackal optimization algorithm to improve the performance of golden jackal algorithm. Okay, so here the golden jackal, it is having what is that? It will sort the prey, it will pursue and capture the prey, and it will attack the prey. So these are the mechanisms are there. Now, what is opposition based learning? This is very much useful. You can pick any algorithm and you can use this technique, opposition based technique. Your paper will be 100% accepted. Many people, they have done the OBL opposition based learning. But what I'm suggesting, you pick some new algorithm and you can, if you're implementing, then your results will be improved. Then you can implement any real life problem or you can propose also. If you're proposing OBL with any new algorithms, means the reviewer are going to accept. Okay. And so people are encouraging this one. Okay. So instead of proposing new algorithm, you can add some technique to improve the performance. Okay. So here, what the OBL is doing, OBL, what it is doing, here the L is nothing but the lower limit, U is nothing but the upper limit. Okay. So here you can see this is the mid position. For example, this mid position is 0 and lower limit is -5, upper limit is +5. So in the OBL, what it is doing, the negative will go to the exactly opposite to the +5 and the +5 will become -5. So if you are there in the left hand side, you will exactly map to another number, same value. Okay. If it is, for example, -3, then it will map to the +3. So you can see Z is mapped to the Z cap. Similarly, Z cap you can map. So direction this side also you can do. Okay. So exactly what is that? Opposite number. Exactly opposite number. So how you can write the equation? The equation you can write very easily. Okay. So if it is, for example, you can write this middle position, for example, 0. Okay. So here value is Z. So you can write the equation, the middle position minus Z. So minus Z if you're writing, then the updated position is Z cap. Z cap is nothing but middle position minus Z. So if you're writing this, if Z value is -5, then middle position is 0. 0 minus of -5, that means 0 plus 5, it will be become +5. If your value is +5, then what it will be? 0 minus 5. So it will become -5. So exactly opposite value, value won't change. Only the sign will change. If it is plus, it will become minus. If the middle value is not 0, middle value is something else. So exactly same position, it will shift to another point. Same position. From here lower limit, whatever the distance, same position will be from the upper limit. Understand? So by doing this one, what is happening? By doing this one, we will have the initial position. Na? So all the position, all particles position will get shifted to another position. But here one condition will give Z will be shifted to Z cap only if its objective function value, its fitness value is better than its previous best. We'll apply the OBL, but there we'll give the condition Z will get shifted to Z cap if Z cap's fitness value is better than Z. So by doing this, our initial 100 particles will be there. Now 100 particles position will be there. So each particle will shifted to another position. So Z will be 100 particles we will have. Then we will have 100 opposition position will have. So 100 plus 100, 200. So among these 200, we can take the best 100. So what is happening here? So initially you are having the 100 position, but some position were inefficient. They may not give the good optimum solution. Okay, they may not give the good results. So here what we are doing? So we are taking the opposition position so that 100 position initial were there, another 100 position opposition. So total 200. From 200 we will pick the best 100. So that means the initial solution we are taking, that is already improvised position. That is already the better solution. So among them, you can find the best one, or you can improvise them. You can send them in a direction. The result will improve further. Getting another. So the opposition based one, very good, nice technique. Okay. Then we can have for the 2-dimensional, 3-dimensional also. 2-dimensional is here. This is 1-dimensional. Only X is there. 2-dimensional means you are having X and Y. 3-dimensional means X, Y, Z is there. Exactly same one. If you are having the P, if it is having the maximum value, you see here, X value maximum, Y value maximum. Okay. So it will get shifted to X value minimum, Y value minimum. See here you try to understand. If it is a less value, if it is -5, then it will get shifted to +5. That means if it is a less value, it will get shifted to bigger value. And if it is a bigger value, for example, +5, it will get shifted to, if it is a +5, it will get shifted to -5. That means smaller value are getting mapped to the bigger values. Bigger values are getting mapped to the smaller values. Are you able to realize or not? So the same thing is applicable here. For two-dimensional, if your X value is high, Y value is high, so your position is here. So you will get shifted to another position where your values will be less. So that means if your value is, what is that? Here I'm not taking 0. So 0 means it will be there in the negative position. Middle position I'm not taking. It is not necessary. Na? Middle position will be 0. You can have in between 1 to 10. So middle position is what? Middle position is 5. If you're having -10 to 10 means middle position is 10. Depending upon the scenario, whatever may be. Okay. So if it is a middle position 0 means this position will be negative. Negative means it will be positive. So I am showing the, what is that? Middle position some 5 something. So if the value is 10, then or value is 8, then it will be under middle position is 5. For example, 1 to 10. The 8 will get shifted to where? 2. 2 will get shifted to where? 8. And 3 will get shifted to 7. 7 will get shifted to 3. 4 will be go to 6. 6 will go to the 4. Then middle position is 5. 5 will go to 5 only. Understand or not? 1 will go to the 9. 9 will come to 1. 2 will go to 8. 8 will go to 2. 3 to 7. 7 to 3. Like that way. So here, if we are having the maximum value, it will go to the minimum value. The minimum value will go to the maximum value. By doing this, see, we don't know whether the maximum value is better or the minimum value is better. Okay. So whichever is better, you cannot choose Z and Z cap both at a time. Which is better, you keep it. Which is not good, you discard it. It is as simple as it is. If something is better, not just is that using the opposition base, you are getting one position. That position knowledge you are not having before. So you explored one new position. You see if it is can be useful to you. If it is useful to you, you keep it. Otherwise, you throw it. Very simple. Understand or not? So similarly for three-dimensional also you can propose. So this is about the OBL method. Okay. So what we propose, we just a minute. It is Sarda. ଆରେ ସେ ଇଏଟା ମତେ ଦେଲାନି କାଲିର ଯୋଉ ପିପିଟି ଟା କରିଥିଲା ଆମେରିକାନ ଜେବ୍ରାର ପିପିଟି ଟା ମତେ ପଠେଇନା ଆମେରିକାନ ଜେବ୍ରା ପିପିଟି ଟା ପଠଉନ କାଲି ଯୋଉଟା ରେଡି କରିଥିଲା କାଲି ଯିବ ବୋଲି କହିଲି ବା ଯଦି ମତେ ଦଉନ ଯାହା କରୁଛ ମୁଁ ଖାଲି ଦେଖେଇ ଦେଉଛି okay so what then we were discussing the OBL. Then you are having the another method ROBL. ROBL is nothing but the random opposition based learning technique. Okay. So here what it is doing, the same equation, but here it will multiply random instead of going to means 1 will go to 9 or 2 will go to 8. Okay. Here 8 will go to the negative value, will go to the positive value, but it can choose randomly. It can choose that randomly. Okay. So negative value will go to the positive value will go to the negative value, but it can choose randomly. That is nothing but the ROBL. So here you can see Z was negative, middle value, for example, 0. So the Z was negative, it can go to the positive value, but it can choose randomly. Anyone it can pick. Similarly, the positive value can go to the negative value, but it can choose anyone randomly. Okay. So by doing so, it is not like that here only 5 positions, here 1000 positions are there. It can pick anyone, depending random value will be in between 0 to 1. it can be 0.5 random value will be generated, okay, by computer. So depending on the computer, it will choose one value, and if it is better, you keep it, otherwise you discard it. So it is just a preliminary intelligence it will give you to choose the position. So once you are having the best solution at the first step itself, if you are having the best solution, then obviously your algorithm will be improved. So you can apply OBL, ROBL to any algorithm. 100% it is going to give you better results. Okay. Then you are having the FROBL. This one we have proposed in knowledge-based system that 8.impact patent got published in last month only in May 2023. It is available online. So this FROBL is nothing but already OBL was there. Random output already FROBL was there. Please mute yourself. Already FROBL was there. Sorry, what is that? OBL was there, ROBL was there. We proposed the FROBL, and it is nothing but fast random opposition based technique. So what it is doing? The random based means that OBL was just only M plus your position or M minus. If it is a negative means it will come to the plus side. If it is a plus side means it will go to the negative side. Okay. So the only M plus position or M minus position. Okay. But now in ROBL, what happened? One random was multiplied. Okay. But here in FRBL, we introduced the concept of sign, and sign with rand square we introduced. And with that, what happened? So instead of choosing just randomly, if you're having the sign means we took that sign concept from the sign cosine algorithm. Okay. So sign function is it is a periodic, and it will give you the better value than the OBL and ROBL. So it will maintain the exploration. Exploration means your diversity. It will maintain the exploitation. Exploitation means nothing but your convergence very nicely. Which one? FRBL. So FRBL is very much efficient, and it is whatever it is. It is giving you the results very nicely. Okay. So and it is what we have seen. What we have seen that it is um, performing means extraordinarily it is performing. Okay. So okay. So what are your future works? Your future works is possible. You can propose several algorithms that there are several algorithms are there. You can propose. You can propose how you can modify those algorithms. You can do the what hybridization of those algorithms. You can you can what is that? You can apply those algorithms to solve the problems. So you can do many things. Okay. So what you can do, you can modify those evolutionary algorithms. You can do the hybridization process. Okay. You can hybrid means you can add it some other algorithm. You can solve the engineering problems. Okay. Using these algorithms. Okay. So the modification, like we said, na, like you can add new operators, like we said that OBL, ROBL, FRBL. You can update the mechanism of population also. You can change. Okay, several different ways and you can change the parameters and parameter by changing the parameters of these the algorithms are very much parameter sensitive. Okay, so by changing the parameters also you will get the better results. Okay, you can solve many real life problems. Okay, so many real life problems such as what is that pressure vessel problem, speed reducer problem, welded bed problem. These are classical benchmark problems. Okay, real life problems. So people are using it in their manuscript. Okay, whenever they are writing in a algorithm, they are using an optimization algorithm. They are using this problem to test their proposed work. Okay. Then benchmark functions also you are having. There are several benchmark functions CC 2005, CC 2007, CC 2019. Several benchmark functions are there. So people are using those functions to test the results also. Okay. So that is also people are doing. And what once your algorithm is ready, then you can what is that check with the benchmark function CC 2005, 2017, 2019, even 2020 also came, or 22 came. So you can test with those benchmark functions. There are unimodal, multimodal, fixed dimensional, so many varieties of problems are there. You can test with those functions. Then you can check with the convergence graph. You can do the statistical test. Okay, these are the things. So what we got the idea from this session that one second. I'll show you another work. Just a minute. Okay, so this one we have proposed. I'm not going to discuss in today's class due to what is that time restriction. I'm just showing that we proposed this work and it got published in scientific reports. Okay. So this one I'm going to discuss in when after one day. Okay, day after tomorrow I'm again going to present another session. I'm going to present. So that day I'm going to present. So this is the concept of I'll discuss thoroughly how the algorithm was developed. Okay, how we propose the algorithm, and you can what is that? You can get the motivation, and you can propose also one new algorithm. So for any optimization algorithm, there these are the results are there, and so you can see. So for any optimization algorithm, main thing is that you need to take care of exploration and exploitation. Okay, how the convergence is going to happen, how the diversity is going to happen, and then you can write the equation depending upon your what is that mechanism, and then you can balance the convergence and diversity, and you can have the algorithm. So algorithm, proposing algorithm is not that much difficult, although it is time taking because you need to test for whatever you wrote, it will work or not. Okay, you need to test. Okay, so but thing is that, and I would like to say that all our work, okay, it is shared in public platform. It is there. So whether African zebra or FRBL, so you can contact me. I'll share the code. It is already there. I'll give you the link. Okay, so you can take those MATLAB codes and you can implement it. Okay. So proposing algorithm is not a big deal, although it is very time taking. It is very hectic. Okay. But you can propose. Okay. So what I thought in I thought to propose many algorithms. Okay, so recently we are writing one paper on the what is that our Hindu what is that Hindu god Brahma, Vishnu, and Maheshwar. So we used to say Brahma is the Srishtikarta and Vishnu is the Palankarta and Shiva is the Sangharkarta. Okay, we used to say. So what it is doing? So they are actually working. Brahma is the Srishtikarta, we used to say. So Srishtikarta means he created the world, Brahma. So that means the population created. So that paper already we have written and it is giving very nice results. The results also, what is that, has been collected. Paper also has been written and it is submitted to some high impact factor journals. Okay, it is under review. So what I'll give the idea that the Brahma Vishnu Maheshwar. So what Vishnu is doing, Vishnu is what is that? He is managing everything. Means which direction you should move, where you will get the diversity, how you will maintain the how you will do the convergence. Vishnu's role is about the convergence. Okay, how you can do the convergence. And what Shiva is doing, he is the Sangharkata. Sangharkata means who is not performing well, he will remove it. That means who are bad people or who are means to them what he's doing he is like Sanghar Prathan means what he's doing. He's doing he's deleting or he's removing those worst performing solution in the population, worst performing particles from the solution. So instead once deleted means one new particle will be generated. One new particle will come into the picture. So the Vishnu is doing what is that? They're giving the intelligence which direction you should move. So we are giving like who are the good people like Swami Vivekananda, Mahatma Gandhi, those people are following. Okay, so they are the good people. So we have related with our fitness value with those people. So if Mahatma Gandhi type one person is there in our society, so all or some saint person is there, some good nice gentleman is there, then all people will listen to him. They will, for example, Ramdev Baba, or I'm just giving one example. Okay, or there are everyone used to follow someone. Okay, or so everyone will have some devotion power. Okay, so who will have the higher devotion power? People will follow to them. That is the idea. Okay, so that is for the conversation. Diversity. Who is maintaining? Diversity is maintained by Vishnu. No, sorry, Shiva. So Shiva, what it is doing? Shiva is deleting who are not performing, and he is generating some. So, so who are bad people? He just what is that? Give the punishment, and he is killing them, and those people are getting removed from what is that? Our population. Instead of that, new population will be generated. So new population will be randomly generated. So it is maintaining the diversity. So convergence and diversity are well maintained and Brahma's role is about the Srishtikata. He just created the population. See, so nicely this concept we have created and we wrote the paper and let's see whether what is happening. This is just an idea how to propose one problem. I have thought about another idea also. Okay, I'm sharing with you. For example, about the we are having now that 2% scientist. Okay, so 2% scientist means depending upon one what is that one researcher's profile. Okay, how many citations he is having, what is his H index, and how many research articles he is having. Okay, how many papers he is publishing. Depending upon that, one person is there. There are very few people who are there in 2% scientist list. Okay, from our VIT, some 10, 15 people are there. From other institute also, some people are there getting in. So these 2% scientists also can motivate other people like a researcher like us. Okay, we are getting motivated by those 2% scientists or not. We also want to include. We also want to get into that 2% scientist list. So these are working like the what is that convergence. So that can be proposed as a algorithm 2% scientist. This is my preliminary thought. We have not written because we have not done the similar, just preliminary idea. Okay. For example, in the football, you can consider about the football. In football, what is happening? Everyone is moving towards the ball or not. So you can say that ball is nothing but what is that optimum solution? The ball you are moving towards the ball only. So ball is nothing but the your optimum solution. So how you are moving toward the ball that you see that so that equation you can formulate. So all are following towards the ball. So that is also possible. Or even you can write on cricket. People have written algorithm on cat, monkey, so many things. Okay. So you can write one algorithm. Writing algorithm is not that much difficult. It is very much easy. And people, you guys can propose the algorithm. Okay. So this is about, so you can propose the algorithm. And this African zebra, what I was what we have done that we formulated the African zebra. So this is the zebra group. We'll discuss thoroughly. Okay, day after tomorrow I'll take the session. Okay, thoroughly each equation how it has been done. Those things we'll see. Okay, African zebra. So this is about, and if you're having any doubt, you can ask me. Let me stop the present. Yeah, so you can ask if you're having any doubt. Um, any doubt? Hello. Hey, Sarda, Rikti sir Dakilo. Right? Thank you for your session to end for join. কি ফোন করতে
କି ସେ କହୁଛି କି ମୁଁ ଜଏନ୍ କରିଛି ମତେ ଲିଙ୍କରେ ଆସୁନି କିଛି।
ଆଚ୍ଛା ସେସନ ସରିବା ପରେ ଏବେ ମନେ ପଡୁଛି।
ଦେଖୁଥିଲି ସେକେଣ୍ଡ ସେସନ ରେ ଷ୍ଟାର୍ଟ ହବ।
ଦିଟା ସେଟା ଦିଟା କରିବ।